Why is my electric bill so high? Customer says their electric bill was $600. They said it's 3 times that of a normal bill. And they've got a heat pump. And I'm going to explain today, if you've got a heat pump, what can cause your electric bill to be so high. There could be something wrong with your unit, and there is something wrong with this unit, and we're going to figure it out today. You're watching HVAC Tips for Technicians / homeowners. I'm Tad. Let's get started. We're working on a split heat pump. That means we got 1 unit inside, 1 unit outside. This is our outdoor unit. And then our indoor unit is over there. A little bit hard to see, but that is a heat pump air handler. That contains the indoor coil, the blower motor, which blows through the vents, and it contains a heater kit. And if you turn your unit, your thermostat, to heat, that means the outdoor fan should run and the indoor part should run. If you turn it on heat and your outdoor part doesn't run, then that could be the reason your electric bill is high, and that's what we're having today. We turned the thermostat on, the outdoor section was not running. I'm going to show you what to do next. And if you turn it on emergency heat, that's when your outdoor section should not run. So that's when you use your heater kit. And if you're just using your heater kit to heat your home, then that could be the reason your electric bill is so high. Now, let's do some troubleshooting. If we take our thermostat and we push the mode button and we switch it to where it says heat, right? Then that means that in between C, which should be the blue wire, sometimes it's the brown, the black, but it goes to the C terminal on the board, and the yellow should have 24 volts. And that will energize the contactor coil and it'll energize the outdoor fan. What we got? We got 26 volts, right? Right? Okay. So the first step is turning the thermostat on heat and coming outside and checking from C to Y, because we should give a call to our outdoor unit, because that will bring the compressor on and that will start to generate the heat. If we do not have a call, then our thermostat could be bad, or we could have a thermostat wire problem. We had a thermostat problem. That was the first problem. So we replaced the thermostat. After we replaced the thermostat, now I've got a call, but my unit's still not coming on. So why is my unit not coming on? Do I have an issue with refrigerant? I need to check my pressure switches. Since this unit is a heat pump, it's got a defrost board, right? This is what handles the defrost whenever the ice accumulates on the outdoor coil. Since we've got a board, then that means that the 24 volts come from the thermostat. They come to these thermostat wires and then they go to the board, right? And there should be a C, okay, and a Y. You see the Y and then C all the way on the right side. We've got the blue wire, which is C, and then we've got the yellow wire, which is this purple and blue, or pink and blue. So we should have 24 volts from C to Y. Now, this board, whenever it gets the call, then it will send a signal from that board to the contactor coil, and it'll energize the coil. But if there's a problem, like a pressure switch issue where we don't have any refrigerant, then the pressure switch will be open, and it'll keep the signal from going to the board, and then that'll keep the board from energizing the contactor coil. So what we need to do right now is we need to, 1, hook our gauges up, make sure there's pressure, which there's not. There's 0, right? 0 PSIG. So that's the reason our unit's not running. And then we need to check across our pressure switch. So here's the schematic, and it says we've got a low pressure switch, LPS, and we've got a high pressure switch, HPS. And then you can see our defrost board here. Oh, there's HPS right there. There's LPS right there. And we've got a yellow and pink wire that go through that switch. And I'm going to bet this is the reason that our outdoor unit is not running. So I'm going to show you how to check across that now. So I'm going to show you where we're going to put our meter leads. You see the yellow and pink right here? They go to that pressure switch. If we follow those wires up, you can see yellow and pink comes from PS1, right? Follow that wire. Goes down, goes through the low pressure switch, back up, and then goes back into PS2. So if we check from PS1 to common and then PS2 to common, we should have 24 volts on both those terminals, unless the power is not going through, right? Let's do that now. All right, so on the board we find PS1, which is the yellow wire on the right, and then PS2, the yellow wire on the left. Now we're going to take our meter, turn it to volts AC, and then we're going to go from common or the cabinet, all right, which we can just put, oh, there's a leaf. Put 1 meter lead to the cabinet and 1 meter lead to PS1. We'll do the right on the right first. Look, 27 volts. All right, now we're going to go to the other side. All right. All right, now we should have 27 volts. 0. So now we just figured out. So our pressure switch is open. We're not sending the 24 volts through that switch, and therefore the board is not going to send 24 volts to energize the contactor coil. If the contactor coil does not send power to the compressor or the outdoor fan, then our outdoor unit is not going to run. That means the homeowner or customer has been using their electric heater kit, that indoor air handler, the blower's been blowing, the heater kit's been energized, and that's what's been their source of heating throughout the winter. So if you don't use your heat pump in conditions, especially when it's above 32 degrees, then you are going to have a lot less efficiency and you're going to have a very expensive electric bill. You need to use your heat pump instead of your heater kit when you have temperatures that are above 32. So we need to figure out why there's no refrigerant, and we need to fix the leak. 3 places where we may find this leak. 1 is in the outdoor section. 2 is in the piping, the line sets connecting the indoor and the outdoor section. And 3 is the indoor section. We're going to start at the outdoor, and since there's no refrigerant, we should be able to find this leak because it's probably a big leak. If we had half of the refrigerant gone, it would be a little bit harder to find. But since there's no refrigerant, should be pretty easy. Now, before we put nitrogen in this unit, we're going to take and unplug the disconnect or turn the breaker off. Because whenever we put nitrogen inside the refrigeration system and we get the pressure up, we don't need that pressure switch closing and the unit operating or coming on with nitrogen inside the refrigeration system. So I got my gauges hooked up. I'm going to go ahead and put some nitrogen inside the unit, and it says the design pressure for this equipment is 450 psi, so we're going to put about 350. All right, as soon as we started filling up the system with nitrogen, we heard a click. That click was the pressure switch closing, because now we have enough pressure to close that switch. So I want to show you real quick from common, which we can use the metal frame here, to PS1, we got 26 volts coming in. All right, and then go to PS2, and we got 26 volts coming out. So that pressure switch is closed now. So I'm so glad that I pulled the disconnect. That way the unit didn't run. If the unit didn't have a pressure switch, a safety device like this, and the unit ran without refrigerant, the compressor wouldn't last very long. So I'm glad we do have that safety. And the manufacturers that do include a pressure switch, thank you so much, sincerely. Now, we've got 262 PSI, so I'm going to increase it and add about 300, and then we're going to start searching. So we got about 400 pounds, and it is slowly leaking out. You can see the gauge actually go down, and I've got the rest of the screws out of the top. This is the first section I am going to check. Got one more screw, don't I? No, I don't. Get the top off the outdoor unit, and the first thing I'm going to do is look for visual signs of oil, and if I see anything, which I do, I think, and if I see anything, then maybe that's where it's leaking. You can also use a leak detector, but I'm not hearing anything. I'm not really seeing anything. So I'm going to keep looking, and hopefully we'll be able to find it. Found the leaks. Take a look. Spray this real quick at this braze joint right here. Look at that. Looks like somebody didn't know how to braze. And you can see the bubbles. And you can hear it actually, so this is where it's at. It's definitely leaking right here. taking and removing all the nitrogen out of the system. Now that we've removed all the nitrogen from the system, we are going to remove the old filter dryer and replace it with a new one. You should always replace or install a new filter dryer whenever you open up the refrigeration system. And since we don't know how long this has been like this without refrigerant, we definitely need to install a new filter dryer. For a straight air conditioning system, which is not a heat pump, it can be a gas split or it can be a straight electric where you got electric furnace inside. Not a heat pump, you need a single direction filter dryer. If you have a heat pump, you need a bi-flow filter dryer because the refrigerant flows not only in one direction but in two directions, right? So we've got that arrow that points both ways. It's called a heat pump filter dryer or a bi-flow filter dryer. So we need to open up the panels, this panel and this panel, to get to the filter dryer so we can replace it. And then we're going to wrap this valve right here so we don't overheat it whenever we solder or braze this connection. If you don't know anything about brazing, you want to learn how to braze copper using nitrogen, then check out this video right here or check out my how to braze copper video down the link in the description. This filter dryer is in a terrible spot. I'm going to use the right angle attachment here for the drill to be able to loosen up both the straps because there's no other way to get these two screws loose. There's one. Oh, just slipped out. And then here's the other one. All right, now at least filter dryer can move up and down. So, all right. All right, so we're gonna go ahead and braze up that suction line connection to our outdoor unit suction service valve. And I've got a wet rag here because we don't want to damage the suction service valve. So we're going to wrap this around that valve before we start brazing that pipe connection. All right, we don't have any more refrigerant in here. And what you want to do is you want to put a wet rag over that valve when you're going to braze these connections. Either one of these valves, if you braze near that valve, always wrap it. All right, we're using some Seal False 15. We're using a turbo torch because it's going to be much easier than using oxygen acetylene for this larger pipe connection, although it's only 3/4, but it'll heat it up a lot faster. And there's the turbo tank. Open it up. Wire. Piece of Taddy. That's definitely a lot better than before. Now, before we replace the filter dryer, I do not want to cause a fire, and if you've got dry leaves, then they can catch on fire when you're brazing. So I'm going to take and clean all the leaves out of the bottom of the condenser. Whoa, that is a lot thicker than I thought. Yummy. You know, anytime you go to repair a unit, even if it's leaking, if it's dirty, go ahead and clean it. Because sometimes you can go do a service and clean, and if you left a few leaves in the bottom or the top is dirty, the homeowner is going to go, well, you didn't really do a good job. So you want people to look at your unit that you just serviced and go, wow, they cleaned it. They did a good job. You know, because sometimes even though you worked really hard, people don't see it. Definitely over here. That's a looking a lot better. All right. Wash the rest of that out here in a minute. All right, since we've got a pressure switch close to the connection that I've got to braze, I'm gonna wrap a wet rag around this pressure switch because we don't want to damage it. So I'm gonna get that done. A pair of adjustable pliers or channel locks to be able to grab the copper when we heat up the connection connected to the filter dryer. We'll be able to pull it out using these pliers. You can cut out the filter dryer on each side if you want, or you can use a torch and you can unbraze those connections. I'm just going to use a torch. Connection. All right, now take your channel locks and grab a hold of the top of that filter dryer and then heat the bottom. All right. Now we got that filter dryer disconnected. There it is. Perfect. All right, so let's take both of these fittings on the end of the filter dryer. What are you doing? Take it off, please. There you go, Tad. Good job. Take this one off too. Sometimes there are these covers on the ends and then there's a little piece of rubber. Make sure that you take all of them off. All right, now let's put it in place. Careful not to burn yourself. Filter dryer is in place. Now I'm going to braze the two connections. Again, my solder. It's really hard to see that braze joint on the bottom. Make sure you're using an inspection mirror, that way you can actually see both sides. And then you may need to bend your solder, that way it's angled back so you can get the back side of that copper. Since it's 3/8, that's a very small pipe size, should be able to heat one side of that copper pipe and the whole entire pipe should get hot enough where you can melt that solder all the way around. Now, I wanted to make sure I showed you this. This is a wet rag around the liquid line service valve. So we want to make sure that we do not get those valves too hot because we don't want to damage them and then have to order a valve. Putting nitrogen back in the system. I'm going to use my soap bubbles and test all of the connections and see if I got a leak. All right. Like about 330, and then we may just let it set here. This right here is a little inspection mirror. You can use this when it's hard for you to see your braze joint, maybe around the back side of the joint. You can see that with an inspection mirror. If you don't have one of these, you need to get one of these. This may save you some time. Now we're pulling a vacuum and I have got the top back on. I got to put the screws in. We got the new filter dryer. I'm using an adapter cord, taking my power from the contactor coil because there's no outside receptacles. If you don't have an adapter cord, check out the link in the description or get one right here. And make sure you always wrap these valves because you can have leaks right here on the very top when you take the cap off because somebody installed a unit and didn't wrap a valve. It's that easy. All right, I'm gonna let the pump run and pull a vacuum, and then when I get back from lunch, charge it up. Almost there. Got the scales and the refrigerant ready. This unit is 410A. I'm gonna zero out the scales, see how much refrigerant we need. Factory charge an ounce 410A, it looks like 100 ounces. So 100 divided by 16 is 6.25. All right, now we're gonna add through the liquid line. We're gonna charge liquid into the liquid line, and we're gonna factory charge. All right. Got a half a pound so far. Also, I am going to replace this customized metal insulation here. This Armaflex. Got some new insulation. 1.5 pounds almost. Look at that braze joint compared to earlier. Oh, pressure switch did close, yes. Got the disconnect pulled out. I'm going to go ahead and reconnect these wires to the contactor coil. All right. I can go ahead and plug in that disconnect here in a minute. 2 pounds so far. 5 pounds, 13 ounces. Looks like it stopped right there. 5.8. We're almost at 6.2. We'll go ahead and plug it back in and then finish the charge. Heat pump is working. It's fully charged, factory charged, and we just finished checking superheat and subcooling, temperature split. If you don't know how to charge a heat pump in the heating mode, definitely check out the video that I put down below for you to learn more. If you don't know how to hook up your gauges to a heat pump, I'll put a little short down below so you can learn how to do that. And if you guys want more videos like this, go check out my playlist, HVAC Tips for Technicians. Show you the gauges. 63 on the low side, 310 on the high side. Looking pretty good. We added 5.8, then we added 0.4. And this is how I've got my gauges hooked up. This port goes to the suction line of the compressor, and then this is our hot gas vapor line during the heating mode. So, good deal. It's working. I just did a video on how to know if your emergency heat is working. If you want to learn more about emergency heat, check out that video in the link in the description. You've been watching HVAC Tips for Technicians / homeowners. I'm Tad, and I'll keep you cool if you let me.